in the S-plane, if you remember, we have root locus, right? Or in other words, you just plot in the S-plane, S, alright? So you have a pole, you plot the pole over here, you have a 0, you plot the 0 over here, and you know that this right half plane is out of bounds, right? Because it's unstable. Now, Z-plane. Z-plane is something like a S-plane, but in terms of Z lah. Alright, so Z is equals to ES of T. Alright, S itself is in terms of we can represent S is equal, because S is in terms of sigma plus j omega, imaginary and real. So EJ theta is also equals to cosine, which is a real value that represents sigma and a imaginary value that represents in the J plane. So using this formula will actually create a circle. You can actually plot the theta, and then in terms of radian, you should get a circle. Alright, and the radius is r. So later on I think we'll talk about it. But now, let's talk about the trend, how they move. First of all, n, if you talk about 2 pi, you're going to talk about n, which is the number of cycle, meaning how many times you turn around this loop. Alright, and therefore somewhat you are translating S2, how do I say? You're representing S2 in terms of its previous points, I would say. But in terms of, like, for example, this point over here will somewhat map onto this point. And this point over here will somewhat map onto this point, and the other point maps onto this point, and things like that. Alright, I might not be exactly mapping the correct point to the correct position, but at least using a certain equations, I believe is this equation, we can actually take this point and translate it into this point. Alright, and the angles, I will believe the angles, for example, the sum of angles between the zeros and the poles for this S-plane will be the same for the Z-plane. I don't know yet. Later on we see how it goes. I will highly believe that it doesn't change. Okay, let's continue. Okay, let's do this one. Okay, since I think the angle is something different. The meaning is totally different. So don't take it for real for my angle that part. Alright, just now what I say for the angle part. Alright, I think as if that I didn't say it. Alright, I take back my words. But the S equals to real and J sigma, I mean, like, you know, imaginary, we can still take it. Now, the understanding is that, let's say I plot this point over here. For example, I plot it over here, this point. And as I plot, I will go and turn in this manner. And as I plot, I will go in this manner. So as I go up, I will go in this direction. Okay? And as I all the way go up, it will all the way 2 pi, turning like macam don't know what the hell. Okay? Now, this one is in terms of plotting the real axis, so we're gonna go in this manner, anti-clockwise. It was going in the, not real axis, but I mean like going upwards in the imaginary axis. Now if we were to go inside, downwards to the imaginary axis, I will highly believe that the rotation may be going in this direction. It will go in this direction, clockwise. So for this system, you'll go in the anti-clockwise. I'll leave you to think about it in the future. Alright, but still, for the bottom half, alright, for the bottom signal, you will also circulate 2 pi. No matter how many times you go, for maybe 10 to infinity, how many times you go will plot in terms of this circle only. That's all. Now, the further you go, alright, the further you go, the more you are going towards the origin. Okay, so if you go infinity, origin is the infinity. Okay, then this line, this particular line, when you plot each of this plot all over here, you're gonna plot into this point, plot into this point, plot into this point. Okay, so the further you go, alright, in terms of the imaginary and the real, together one set. Just now we talk about for that certain drawing the circle, right? Drawing the circle, we're only talking about the imaginary axis, this axis only. Now we're gonna talk about the interactions between the both axes. Alright, so the more you go in terms of this imaginary and real, the smaller your circle will be. So in this case, this is the green one, it's over here, right? If this is the red one, then it's over here. If let's say over, alright, if you are in the more unstable region, this means you're bigger than the +1, if you still remember, in the unit circle. So at least you get what I mean, because if you were to go further down to the left half plane, this means that you're becoming more and more stable, and therefore your problem is becoming smaller and smaller. But if you're going to go inside the right half plane, you're going to kill yourself, then your radius will going to become bigger and bigger. Some sort of the meaning lah, okay, macam. And as if you have a damping factor, alright, if you still remember, although I don't remember, but if you have a damping factor, for example, you actually, if you are going in this direction for this point, you're gonna plot into this point, and this point you're gonna plot into this point. So as the more you go, the larger the magnitude, the further you are, the further you are, something like that. Alright. Last but not least, we are going to talk about this trend. Alright, this is in the S plane, this is in the Z plane. In the S plane, it's quite apparent is that at this real axis, alright, your stuff is simply this one, and this one. Alright, this one is when you're further down, this one is when you're further down, this one is exactly at this point. That's all it is. Alright. So as this point over here goes up in the imaginary axis, this will oscillate. As this one goes up, it has the same pattern, but it oscillates also. Alright. And as you go up further, this one will oscillate more. Something of that meaning. And then over here you oscillate also. Oscillate in this manner, going up. Right, this is going down, something like that. Now, if you talk about Z plane, then it's something less apparent than this one. It's in terms of this one. If you take a look, this circle is stability. Alright, this circle is similarly like your imaginary axis. If you still remember, your imaginary axis is going upwards in this manner. So when you go up, you're gonna plot the circle. So therefore, at this particular point, alright, this is where you start, which is at your origin over here. So at your start, it is a pure flat signal. So as you go up, here it becomes oscillatory, right? And therefore as you go up, these signals become more and more oscillatory. Over here, he take this point, and where is it? He only got one picture. Okay, now as you go further down, in the real axis and the imaginary part, or perhaps I should say that in the real axis now, if it's in the real axis, know that as you go in towards infinity, you're gonna go from origin. Alright, this is where the origin start for the S plane, right? So the origin start for the Z plane is actually here. I mean not origin, but rather than where it starts from the unstable to the most stable is what do I say? From origin we go towards infinity, means more and more stable, right? And for this point, this is after which is unstable already, right? So from this point to this point is exactly the same as from this point to this point. It's the same thing. So therefore, the more you go, the higher you decay, the faster you decay, or something like that. So therefore, as you can see, it's over here, and then it is over here. So you decay more and more. You decay faster and faster, as you can see. You decay so fast. This one decays slightly faster. This one less faster. Okay. Now, as your real part goes into the imaginary, meaning this whole plane, missing imaginary and real. So real and imaginary will have something like an oscillatory, right? Something like that. Actually, this graph is for this point over here. Alright, this graph over here, I keep drawing overlapping. This graph over here is for this point. Alright, don't mistook that is over here means that is inside this plane. Don't think that. Okay, so if you're talking about imagining a rail, you're gonna have the so-called the trend of the rail system. Like for example, the rail is something like this. Alright, if you go to imaginary side, it will become something like this. Sorry, something like this. So you have this trend, but it became oscillatory, and therefore this also explain this thing. So as you go further out, into the imaginary axis, alright, you're gonna be somewhat more oscillatory over here. Okay, and at this point, this is less oscillatory, as you can see, because it's going from this side to this side. Okay, imaginary, you have less oscillatory. So at this point, so in other words, at this point, this is simply something like this. Alright, maybe I shouldn't say like this. Yeah, correct, should be like this. Then along it goes to the oscillatory part, meaning as you go up in this path, this signal will become more and more oscillatory. At this point oscillatory, and at this point super oscillatory, something that's shown over here. And as for the last part, this part over here, what do you see? It's actually towards the right half plane already. So towards the right half plane, the trend of the graph is actually going in this direction, and therefore as you can see, it's going in this thing. It's going in the oscillatory upwards. You see? Therefore, what I can conclude from here is that the meaning this line over here, when you draw this line, means that you are drawing a circle. Or in other words, if I draw this line, this means I'm drawing this blue circle. When I draw this red line, I'm drawing this thing. So as the further you go, the smaller your circle. Where am I? Yeah. So this also explains why the further you go in the rail axis to the left half plane, you actually goes towards the origin, more and more stable. Hope this is somewhat a pretty good summary. And yeah, this is it, and see you soon.